off the windswept coasts of the British Isles, a remarkable new creature emerges. A robot jellyfish with undulating soft tentacles and microprocessors. They were designed not for the ocean's demands, but for our own. The advancement of UN sustainability goals.
That's a Bloombot. But what is it for? Let's rewind.
The United Kingdom isn't just investing in offshore wind, it's betting its future on it. In 2024, the nation's offshore wind capacity stood at around 11.8 gigawatts. But by 2030, the government plans to more than quadruple that, reaching an ambitious 60 gigawatts. It's a bold target with progress underway, but beneath the surface lies a significant challenge: inspection and maintenance.
We spoke to a representative of the leading offshore energy company Everose. They provided us with vital information on the underwater areas requiring the most maintenance and care. Traditional inspections require highly trained, remotely operated vehicle pilots, expensive support vessels and specialised divers, scouring every component from mooring lines to microcracks for deep-sea corrosion. Each inspection means shutting down turbines, losing valuable time and exposing workers to risk.
Operation, maintenance, and servicing costs for a 1 gigawatt farm exceed £75 million annually, with maintenance and servicing taking up 2/3 of that bill.
Crews are deployed using transfer vessels costing £2,500 per day, or for larger service operation vessels up to £25,000 daily. In some cases, helicopters must be used, adding another £1.5 million per year to the bill.
Typical inspections occur only every 6 months due to high costs, limited availability of inspection teams and vessels, and harsh weather imposing too high of a risk for human life. But half a year may be too long. Within this time, many issues may appear in the wind farm. If these issues are not repairable on site, crews may have to bring the wind turbine to shore, which is a financial nightmare due to the severity of the repairs and downtime.
Imagine if we could eliminate the need to send out ships on dangerous and expensive missions to check on what may only be a minor issue. Imagine if we could know about a crack in the weld line of a monopile before it becomes too late. Well, you don't have to imagine anymore. Bloom, a biorobotic swarm for autonomously inspecting offshore wind farms at the subsea level.
Bloom offers rapid deployment, frequent inspection and autonomous monitoring. With Bloom, you can spot issues immediately, preventing minor repairs from becoming major failures.
The actuation technology of Bloombots is based on a hydraulically driven design developed by Frame and colleagues from the Florida Atlantic University. Their study showed that soft silicon tentacles actuated by impeller water pumps can produce strong thrust in open water.
Each pump inflates 3 soft tentacles, inhaling and exhaling seawater. Our design mimics the pulsing movements of the moon jellyfish, allowing for smooth, efficient and mesmerizing motion.
The incorporation of an inertial measurement unit allows the Bloombot to understand its orientation and actuate its fins accordingly to manage underwater disturbances.
This soft propulsion system was supported by Andy Radford, a professor of behavioural ecology at the University of Bristol. He provided insights into the environmental impact of noisy inspection vessels, pivoting us towards a soft, silent actuation system.
Additionally, due to their soft tentacles, bloombots will not cause damage to the delicate environment and wildlife. Not only is Bloom good for your business,
But it's good for the fish.
Bloom offers continuous monitoring. At the heart of this system is the mothership, an autonomous vessel which transports, charges and deploys the jellyfish swarm. Upon retrieval, the mothership draws energy directly from the wind farm, allowing for long-term stay and extended inspection. Bloombots use acoustic communication to relay data back to the mothership. This data will be used for creating a 3D map of the underwater structure, as well as measuring the distance between bots for localizing each agent in the swarm. Increasing the number of agents extends the swarm's range. This scalability can provide coverage from the scour to the intertidal zone. High-frequency ultrasonic emitters will be used to generate this 3D map, whilst low-frequency acoustic emission will be used for distance measuring. Integrated MBUs will act as a backup localization system.
we developed a 3D simulation to demonstrate and evaluate the swarm in real time. 2-meter distances are maintained between bots by attracting isolated peers and dispersing when overcrowded. They are also drawn to the turbine monopile, but repel from already inspected areas. If communication lines are severed, they pulse their way to the surface to re-establish the communication link. From these rules emerges a decentralized intelligence that will autonomously monitor the turbine for any damage or corrosion.
In today's offshore wind sector, underwater inspections are dominated by remotely operated vehicles that cost between £20,000 and £100,000 per unit. In contrast, a single Bloombot costs just £250 to manufacture. For the cost of one traditional ROV, operators could deploy a swarm of up to 80 Bloombots, dramatically increasing coverage, redundancy, and inspection resolution.
Our simulations found that a swarm of 20 Bloombots offered the most efficient and reliable inspection pattern for a typical monopile. This means a single ROV budget could fund a Bloom swarm 4 times over. Our team has built and tested individual Bloombots, validated our actuation system, and completed swarm-level simulations. Our next phase is full-scale swarm development. This includes optimizing the design for production at scale and transitioning to a custom PCB for more efficient integration between subsystems.
On the software side, we are developing localization and mapping algorithms, using approaches like SLAM and Kalman filtering to enable coordinated swarm behavior for inspection. These algorithms will ensure that the data each Bloombot collects is accurately placed in context. Furthermore, we will be designing an interface for clients to observe the inspection data collected by Bloom. The 3D mapped turbine data will be presented in a computer program for easy identification of any damage or corrosion.
With your support, we can take Bloom Platoon from a promising prototype to a transformative solution for offshore wind inspection. Scalable, affordable, and sustainable.
We're rescuing the baby. Aye, it's free. It's free. Go be free.
Just give it a little squeeze.
Go be free.